Bismillahirrahmanirrahim. Today we will discuss about the isothermal process. So there are the four thermodynamic process that we will discuss in today's lecture. The first process that we have the isothermal is it is clear from a word iso means same, thermal means a temperature. So you can see here that this is the thermal means temperature and iso means same. So means the process that takes place at the constant temperature, that is known as isothermal process. Means the temperature the same. For example, that you can see here that we have the two container. This is a container A and this is the container B. For example, if this container or this vessel is at pressure P1 and volume V1 and temperature is T1, and again this vessel is at a pressure P2, a volume V2 and the temperature is a T1. So you can see here that this temperature is a constant T1, so there's a no change in the temperature. If there is a no change in the temperature, then we call it the isothermal process. So mathematically, if we see that in isothermal process, that the heat, that is the Q, that is equal to a work. So means the heat will be equal to the work. So at a constant temperature, there is a no change into the internal energy. So delta U is equal to 0. And according to the first law of thermodynamic, that internal energy is equal to Q plus W. If we put the value of delta U here, so this equation will be Q is equal to W. If graphically we explain the isothermal process, you can see here that this is the y-axis and this is axis. So this is the pressure and this is the volume. So the curve for the isothermal process is in this form. This is the point number 1 and this is the point number 2. So you can see here that there is a slightly, we can say, a decrease in a curve from this point to this point. We have the second process, that is the isochoric. So iso means the same, choric means the volume. So you can see here again that we have the two vessel, one is this vessel and other is this one. So if we see that we are giving or providing the heat to this system also absorbs the heat, but pressure, if the pressure is P1 and the volume is V1 and the temperature T1, so you can here see that this P1 pressure has become the P2 and this volume has become, we can say, the V1. Okay, this is the V1 and this is the temperature is T2. So choric means the volume, means the volume is a constant, so there's a no change in the volume. If you, we can see here that a delta E, this is the internal energy, that is equal to E2 minus E1. So the heat is always equal to change in internal energy. So delta E also can be written like this one. This is a delta U. Okay, so this is a delta U. So if delta V is 0, then there is no work done in the system. Okay, so the heat is always equal to internal energy. Graphically, if we see here that we have the pressure on the y-axis and we can say that the volume on the axis. So if we say this is the constant volume, you can see here that this is a constant volume, but if the volume is a constant, so it means that there is no work done. So if volume is a constant, if a volume doesn't change, it means that work is not done. So we have the third, a thermodynamic process, that is isobaric process. So you can say the iso means the same, baric means a pressure, this is a process. Again we have the two container, this is container 1, and this is also second. So this is the pressure P1, and this is the volume V1, and this is the temperature T1. So you can see here that the pressure here P1 and the pressure here P1, well, pressure the same. The pressure is not we can say the variable. Pressure is not changing here. So volume V1, and this is the V2, temperature T1, this is the T2. If we explain it graphically, you can see here that this is the graph for the isobaric. So the pressure, if the pressure remains constant, so there's a no change in the pressure, there's a no change in the pressure. But you can see here, if at this point, if we see here, this is the volume, and it if I see that at this point and this point there's a change in the volume, but the pressure remains the same. In other, we have the fourth one, that is the last one, that is adiabatic process. So first we have to understand that what is meaning word adiabatic. So this is meaning of word adiabatic. Means not, and dia means a through, and this is batic means a pause. So what is meaning of word adiabatic? So we can write the word adiabatic like this one. So this is impossible. Impossible. Impossible means which cannot pass through. So in adiabatic process, that heat neither enter nor leave the system. So delta E is equal to E2 minus E1. So for the work that we write here, that E1 minus E2, because in this system the E1 is greater than E2. In adiabatic process, that E1 is greater than E2. So we write here E1 minus E2. Generally that we write that delta E is equal to E2 minus E1. But when we talk about adiabatic process, that we can write this, that E1 minus E2. So delta W, this W is always equal to minus a delta E. Why minus delta E? Because you can see that the work is done when internal energy changes. Internal energy changes. So you can see here that in diabetic process that heat cannot enter from outside. So this is no, we can say that the heat, no heat is entering the system. So you can see this is a container, this is the P1, and this is the V1, and this is the temperature T1, this is the P2. You can say this is volume, we can say volume and the temperature. So a diabatic process is also known as a isoentropic. Isoentropic. So isoentropic can be written as the isentropic, because the entropy for this adiabatic process is the same. That is why that this process known as the isentropic or isoentropic. So delta S remains the same. So this is overall about the four thermodynamic processes.